Good morning, dear students. Hope you are doing well and you are following all the sessions in a good, understandable manner. Dear students, as we are discussing the topic image enhancement, we have finished the concept of image magnification and image reduction. Followed by, we have seen contrast enhancement. And in the two methods, we are trying to make the image more clear in such a way it can give the information more accurately about the target, the image. As you know, and we discussed what is contrast enhancement and what is contrast, what is histogram. Hope you all understood what is histogram and what is contrast enhancement. Under contrast enhancement, we have seen two types. One is linear contrast enhancement, the other one is non-linear contrast enhancement. In these two cases, what we are trying to do is to make the object more clearly, to make the image more clearly, in order to retrieve the information of the image of the target. We have seen and you understood hopefully what is the minimum and maximum stretch. And we also discussed the other concept, saturation stretch. Here we are trying to trim the tail ends because most of the images, the image will be, or else the image will lies in the center portion of histogram. We have seen why we are trimming the tail ends of the histogram under saturation stretch. And we have seen nonlinear contrast enhancement. The difference is, in the previous case, the histogram is expanding linearly, whereas here, because when histogram is asymmetric, that means high and up and downs of digital numbers. There, histogram is asymmetric means the digital number values are more peaks and valleys, whereas high and low values. In such cases, a linear contrast enhancement method may not be adaptable. That's why we have adapted non-linear contrast enhancement. Here also we have seen two categories. In the previous case, we have seen minimum and maximum stretch. Of course, the other models are there, but up to the curriculum point of view, syllabus point of view, we are discussing here. Here also two models we are discussing. One is histogram equalization. How we are doing? Histogram of any shape. Here we are converting, or as we are making it in an equalized mode. How can we achieve it? Simply, we can make this process with the following formula. What and how? The histogram equalization. Pixels of an image are reassigned to a certain number of bins. What is bin? The pixel values are reassigned It is certain number of bins. What is bin here? The total number of pixels in the image is divided by the number of bins. That means categories. To perform histogram equalization, the pixel values of image are reassigned to a certain number of bins. And a bin is nothing but total number of pixels in the image divided into the number of bins having equal number of pixels per bin. One bin, one small category. The pixels are categorized into different number of bins which has equal number of pixels. All the pixels are divided into bins and each bin consists equal number of pixels. The formula is A equal T by N. What is A? Where? Number of bins. Total number of pixels in the image T. And A is the equalized number of pixels per bin. How much is the number per bin is A. And how many are the bins? Many categories A. Total number of pixels in each in the image. After that, here is the formula. To assign pixels to output bins, the following equation is like this. And you must remember this equation. And here, keep in mind, we are doing histogram equalization. This is the histogram. Histogram is the graphical representation of histogram, the graphical representation of brightness values of an image is called as histogram, right? This is histogram, of course. It is the histogram. Now, if we done an attempt, if you go for an attempt, the histogram will be like this. So many curves. That is the reason it is asymmetric histogram. In these cases, it is divided into number of bins and each bin consists equal number of pixels. See here, this is the formula and you must remember to assign pixels to output bins. How can we assign pixels to the bins? The following equation is used. The whole process is going to be taken place in the computer monitor. When we are giving these functions or particular principles, the output will be like this. I said that in the earlier case, it involves an algorithm. Which one? This is the formula where A equalized number of pixels per bin, HA the number of pixels with the value I, integer function, output bin number, a particular brightness value considered as input, which is I, and HK number of pixels per bin, K is particular bin number. And this is the formula you must remember. See, when you are writing an attempt histogram equalization, here any shape of histogram can be done, or else can be equalized. Any shape of histogram which has high and low frequency, or else whole range of digital numbers having high and low frequencies. See here total range of pixels categorized into different bins, and each bin consists equal number of pixels, which we can see here, which we can divide with the following formulas: A equal to T by N, where N equal number of bins, T is equal to the total number of pixels in the image, A is the equalized number of pixels per bin. After that, this is the formula to equalize the histogram, to equalize the pixels to output bins. And here is the formula you must remember. And the next one is, and this is the output. Once we applied the formula, this is the output. See here, for what this is the formula to assign pixels to output bins. The following equation is this one. After the whole process, the histogram of high and low frequencies having various number of digital numbers will be like this. Next one, reference stretch. Simply we are comparing the histogram of one image by taking the histogram of another image as reference, and both are, or else whatever we are doing, whatever the histogram we are examining will be modified with respect to the histogram of other image what we have as in a file, which has taken which has the images which has taken at different timings and different days. That is reference stretch. Coming to spatial filtering. The topic is filtering. What is filtering? Here, if an attempt has made to filter based on the percentage, the categories may be first class, second class, third class. If any attempt has made based on what? BTech admissions, CSE, ECE, civil, mechanical, so on. See, so the objective, we are doing something filtering, we are doing something dividing. And what is the need of filtering here? And what is the meaning of filtering here? Filtering in the sense, if consider an image which has 6 rows and 6 columns with digital numbers. At one particular point, if any digital number is abnormal, not matched with other neighboring pixels, we call it as noise. We are not supposed to leave those noises. They have to be filtered. How can we filter? There we have seen under radiometric errors, a removal of random noise we have seen. Here also same, such type of high frequencies and low frequencies will be rectified, will be solved. See what is spatial filters are designed to highlight or suppress features in an image based on their spatial frequency. To highlight or to suppress based on their spatial frequency. These are using. The spatial frequency means it is related to the characteristics of an image. If you remember the element of visual interpretation, there is an element we discussed, associated texture. As the plants are very near, the texture is smooth. As the plants are grown up here and there, the texture is rough. Rapid variation in brightness levels. In an image, 6 into 6 or as 5 into 5, the rapid variations are there. Rapid variation brightness values gives a rough structure to the image. Whereas a little bit simple variations that gives smooth texture. Did you understand? 0 to 255 is the range of pixels. If the variations are more, it gives rough texture. If the variations are little, it gives low, smooth texture. These are used to suppress the noise and image or to highlight specific image characteristics. For suppose, if you have taken an image of one person, or else you have taken your own image and you want to highlight one feature of your face which is so attracting to you, or else if any dot on your face, you may remove that particular dot in that image enhancement. In the same way, in order to suppress or highlight specific part, we will adopt these filters. So what is we have discussed, spatial filtering is used to suppress or highlight the features of the image. The digital number variation is high. The image has a rough texture. The digital number variation is little bit, whereas variation is little, it gives smooth appearance. This is what about spatial filtering. Now, what is filter? Here, filter is an algorithm. It is also an algorithm for filtering the images. Or else we can also call it as in a moving window. It consists a kernel and it's also called as moving window. Another small image moves over the original image and modifies according to its algorithm. Did you understand what I'm speaking here? A filter contains a kernel. What is kernel? You may think that. Sorry, speaking kernel and something else. How can we understand what is kernel? I told you there itself in the radiometric errors, when we are discussing about radiometric errors, 3 into 3 moving windows are kernels. This is the kernel, or else moving window. It works as per the algorithm we have given, or as per the given algorithm. See, filter is an algorithm for filtering the images. It consists an algorithm. We'll discuss what is the algorithm. A filter contains a kernel, also called window mask or as convolution mask. It is another small image that moves. It is another small image that moves on, or as that moves over the original image. It is another small image moves over the original image. For what? Modifies or modification according to its algorithm. It consists algorithm. Which algorithm? What is the algorithm? We'll discuss. First, you must know what is spatial filtering. What is filter? Filter is an algorithm for filtering the images. The filter contains a kernel, also called as window mask or as convolution mask. It is another small image that moves over the original image and modifies according to its algorithm. This is original image and it is kernel, and this is the small image moving on the original image. We will see what it is work, how it is working. Types of filters. There are two types of filters. Number one is low pass filters. Low pass filters in the sense when we can adopt. These are used to emphasize large homogeneous areas of similar tone and reduce the smaller detail. Large homogeneous areas. Homogeneous in the sense similar. Heterogeneous in the sense different. Large homogeneous areas of similar tone, same tone. What is tone? Nothing but a color here. Large homogeneous areas which has the similar tone, to reduce the smaller detail, these low pass filters will be used. How can we achieve this? Simply, there are a number of low pass filters such as mean filters and median filters. What is mean filter? Nothing is there. We have seen removal of random noise there itself. Simply, this is the 3 into 3 window. It is in a kernel. It is moving over the window of RS, moving over the original image to replace this image. If I want to replace the value, it will be here. If you want to replace the value here, it moves one column forward. Like this, the entire image can be modified. See here, what I'm speaking is there are two. One is mean filters, and another one is median filters. See here, the mean filter is a simple sliding window spatial filter that replaces the center value in the window with an average of all the pixel values in the window. We have already seen and we already discussed about this one. That's why I'm a little bit okay. What I can say is explained with a little bit fast. Fast in the sense here, already you know it, and you have corrected random noise here. What we are doing simply, the small window or a small kernel will be placed over the original image to modify the center value of the kernel. Just I want to modify the digital number value of here, so I just maintained or I just laid a small window on the original image. Simply here 5 plus 3 plus 6 plus 2 plus 1 plus 9 plus 8 plus 4 plus 7. Whatever the number we got by 9, because 9 numbers. The center value is here 1, but in the mean filter it is replaced with 5. It is called as mean filter. Next one is median filter. Nothing is there. Here, all the values are in an incremental mode. All the values are placed in an incremental mode. Whatever the center value we got, that will be replaced with the existed value. That is called as median filter under low pass filters. Low pass filters are used to change the small frequencies of large homogeneous areas having similar tone. Understand? Your median filters is also sliding window spatial filter, but it replaces the center value in the window with the median of all the pixel values in the window. As in the mean filters, we have just summed up and average value, and the value, the resultant with the average, the value whatever we got, that will be replaced here by 9. The value is replaced with the central digital number. But here, all the values of 9 columns, 9 pixels laid in incremental order, whatever the value we got, that will be replaced with the existed central digital number. This is what about median filter of low pass filters. Understand? Coming to high pass filters. See here, high pass filters in the sense, what is high pass filters? We have seen here high pass filters. Here, one particular formula is visualizing here. What is it? Simply, high pass filter can be implemented by subtracting a low pass filter image from the original unprocessed image. Here, just remember here, just listen concentrately. Simple high pass filter can be implemented by subtracting what? By subtracting a low pass filter. That means before we are going for high pass filters, we must have a low pass filter. By subtracting a low pass filter image from the original unprocessed image pixel by pixel. Understand? Here, simple high pass filter can be implemented by subtracting a low pass filter image. That means before we are going for high pass filters, we are having the low pass filter image, and that is subtracting from the original unprocessed image pixel by pixel. So, and for how can we achieve? Simply as per the formula, see here, I star equal 1 minus fi plus c, fi dash plus c. See here, where I star is called filtered pixel value, I is, that means here I is original pixel value, I dash average of the window, and f is a portion of vary from 0 to 1, and c is a constant. You must remember this formula for high pass filters. How can we achieve this? Simply subtracting the low filtered image with the original unprocessed image pixel by pixel. See here, it is well known that an image consists both high and low frequency components. The low frequency image can be subtracted from the original unfiltered, leaving behind the high frequency component. And what you must remember here is a formula, I star equal 1 minus fi dash plus c. This is about the high pass filters, and see here we have seen the low pass filter. This is used to large homogeneous areas, and it is mostly absorbed and will be adaptable for the texture, or as the texture where the, which is very, differentiated with respect to digital number values. And here, when you have a look over there, this is used to suppress or highlight the features. We have seen random noise removal. When you are remembered the topic what we discussed in the name of random noise removal, easily you can remember this, you can easily attempt this spatial filtering. What is spatial filtering? And already we have seen today, see here, a little bit add on to histogram equalization. The formula you must remember, you must remember this formula, and you must able to write this formula in your examinations whenever you got the question. See here, and here is the formula, and here also one formula. These two you must remember when you are writing whenever you got in a question. See here, this image enhancement is and a big question. See, which consists different methods. In your syllabus book, they just mentioned as image enhancement. Under image enhancement, whatever you can apply to the remote sensing image, you must learn all the things one after one. You have learned how to magnify and how to reduce, and you have learned how to add and how to reduce the contrast. And here you understood and you discussed and you learned how can you remove or how can you highlight or suppress the features of the image. And here in the spatial filtering there are two types, again low pass filters and high pass filters. Low pass filters means mean filters and median filters. Mean filters in the sense by average you are doing, median filters in the sense in an incremental order. See here 0, then 2, again 3, and again one more 3, 4, 6, and then 10, and then after the 10, after 10, see here, see here, so numbers, see here 15 and 19 7. Sorry, here, see 97 is there. 97 is there. See here, this is 15. Okay, 19 is there, it is 15. And the value, whatever you got, that will be depicted here. Understand? 0 is there, 2 is there, 3 is there, 3 is there, and 4 also here, and 6 is here, and 10 is here. By mistake here this is 19, then 97. The whatever the value you got, that will be in the center portion of the kernel. What is kernel? It is in a moving window. We have seen, see, we have seen almost three types of enhancement techniques, and everywhere that has been divided into subtopics, or everywhere it consists the other internal methods. We have seen image magnification and reduction. We have seen the contrast enhancement. We have seen the filtering. The next one is transact extraction. What is transact and how we can extract the how we can extract the transact, that we'll discuss in next class. See here, every class we are discussing one after one technology after one technology, by keeping view of enhancing the image. See here, in the see we are discussing unit 2. The unit 2 is analysis of image. In the first, that is visual image interpretation, where you have seen where you are observed different types of elements, size, shape, and the pattern association, and then followed by shadow, so on. We have seen almost all the elements, and then followed by, see here, the key elements. I want to show one particular point here. What is smooth structure, texture, and rough texture? See here, low pass filters and high pass filters. Why we are doing? See here, in order to see suppress, or in order to highlight, suppress the suppress the value at a rough texture. This is the rough texture. As the plants are existed here and there randomly, it gives rough texture, whereas all these are in a line and uniform mode, it gives smooth structure. Understand? This is about the texture, not structure, texture. we have seen, and radiometric correction, geometry correction we have seen, and we are discussing about the image enhancement. And hope you understood today's main topic, that is filtering, spatial filtering. See here, when you have a question, write a detailed notes on so and so topic. You may have a question, right? I mean, contrast enhancement. You may have a question separately, write a notes on image enhancement. I mean, image magnification and reduction. Everywhere you must use the pencil. That's what I'm speaking from the beginning. You must use your pencil and your scale, and the digital numbers keep in mind 0 to 255. And here, while you are listening this class, it will be very easy to you, but when you are attempting the answers in examinations, it gives, you may not remember, because I told you in the beginning itself, the terminology is different when compared with the other subjects. Okay, see here, scan skew, non-mirror velocity, here under geometry correction, and then non-systematic correction, followed by miscellaneous pre-processing, then image enhancement. Why keep on making you remember is, see here, the last session, unless we are not making you remember, most of the people may not remember what happened in the previous class. That is the reason I used to connect the topics. I used to connect the topics with one another when we are discussing the fresh topic. See here, and here, hope you understood why we are going for, histogram stretch, because here it is a place 0 to 54. That is the reason we have gone. We just in the stretch we just stretched the histogram here as in a minimum 0 and as in a maximum 255, because here is a place 215 to 255. Understand? That's why we went for minimum to maximum here, but there is no such type of possibility. That is the reason we are just trimming the ends, because the center portion of the histogram mostly lies the information of the image or the target. Understand? And here, and followed by non-linear contrast enhancement, where the algorithms are using. This is what about the filtering. This is what about the contrast enhancement. What is contrast enhancement? We have seen. See here, what is contrast? The range of brightness values present on an image called as contrast. What is histogram? A range of brightness values in a graphical representation that holds an image is called as histogram. What is contrast enhancement? With the process that we are doing to make the features of the image, or as to stand out the features of the image more clearly in order to retrieve the information of the, or as by keeping view of retrieving the information of the image, that is called as contrast enhancement. See here, why we are adopting this contrast enhancement technique, because certain images are low dynamic. See here, within which are sometimes the images may be existed within low dynamic range of that gray level image. In such cases, we have no option. We must increase the contrast. That is the reason we are going for contrast. Why we are going for image magnification and reduction? See here, normal computer screens are not compatible such a large data of remote sensing. In such cases, we must reduce the data. How we can? Simply we are going for, based on our requirement. How can we why we are magnifying? To go for specific task, specific point, we are going for magnification. And how can we go? We have seen 2x magnification and 2x reduction. And why we must go for filtering? See, sometimes, see here, in one particular image, if for suppose consider an objective, what we are captured in that images, sometimes there might be some red spots. You may be uncounted. Sometimes you may be observed certain spots that you must remove them. How can you remove? Simply, we just name them as random noise. Simply applying these type of filtering techniques, mean filters, median filters, where you can apply these low pass filter and where you can apply high pass filter. See, Low pass filters means for large homogeneous areas. See your large homogeneous areas which has a similar tone, there you will go for low pass filters. Where you can go for linear contrast enhancement when the histogram is expanding linearly. Where you are going for non-linear contrast enhancement when the histogram consists, or as when the histogram is asymmetric. Asymmetric in the sense the variation of digital number values are vary in the sense high. In such cases, we'll go for non-linear contrast enhancement. When you can go for high pass filter, see when the area is rough texture, when the area consists the high variation of digital number values, we'll go for high pass filters. In the high pass filters, we have seen the formula, and here low pass filters will go for either two methods, any of the method. One is mean filters and the other one is median filters. Up to this particular point, hope you understood. Now we'll go to the next topic, in the next class. Thank you. If you have any doubt, you can contact me. You can contact me at any of the domain, whatever you feel convenient. Here we are at the we are discussing second unit. Hope have a look in the first unit what we discuss by listening that a scattering, Raman scattering, relay scattering that you must remember. See here, as I told you, the first unit is remote sensing. The second unit is remote sensing. See, after image enhancement, see what is the topic is image classification. How can you classify the images and what are the different types of classification we are going to discuss after this topic. That means here you learned how can you modify the images, how can you modify the image properties. In the first unit you have seen what you have seen, how the image will be captured by the sensors, how the image will be reached the processing stations. Once it's reached the processing stations, how can you and how can you modify and how can you analyze. That's what we are observing here in second unit. After this unit we are moving into the third unit, that is GIS. That means as per we are discussing the syllabus point of view, I told you in the first class itself the first two units are remote sensing and the next two units are GIS, and last fourth and last two units are combinedly, that is applications of remote sensing and GIS. And fifth unit, see exclusive some part is there that is mentioned in curriculum with respect to water resource engineering, how and what are the different applications we are going to discuss. Here what I'm speaking is today, dear students, see here after listening these classes, don't leave the classes the way after listening of the sessions. Try to remember these words and try to remember the terminology that lies in this particular subject, because I am keep on speaking with you. See, you're listening and hearing, and while you are listening these sessions, it may be you may feel that it is very easy, and but when you are writing, unless you are not preparing well, it is difficult to attempt examinations. That's what I have allotted time for this session, just to ponder on the topics what we discussed earlier. Hope these three method, three techniques you are, well content about the, magnification, reduction, contrast, enhancement, and filtration. In the next class, we'll discuss the other technology or as other method where you can enhance the image quality. I told you that if you have any doubts, please contact me in the domain whatever feel convenient. Thank you. I will meet tomorrow. Thank you.